Hi everybody, welcome back. Have you ever heard someone say, "This graph clearly shows," but you saw nothing in that graph? What does it take to be so proficient with a visual that you can just see something in it? We actually all have that level of proficiency with some visuals. Take a traffic light, for example. When it turns from red to green, we don't have to pause and ponder what green stands for. We just see it and go. I wrote about this in an article that just came out that presents my research, which shows that there are actually two skills that go into this level of proficiency. On the one hand, we need to be able to explain how a visual shows information. In a pie chart, for example, you can explain that a shaded wedge usually is a category that we're interested in, and the size of the wedge corresponds to that category's weight relative to some total. So we need to learn about visuals by explaining. On the other hand, we also need perceptual intuitions. When we see a pie chart that has a wedge highlighted, we can immediately see how big that category is. And these intuitions come from experience with many pie charts, which gives us a rough idea whether this is a big or a small category. So we need to train our perceptual intuitions as well. In my research, I develop educational technologies that support both skills. Specifically, I focus on helping students translate between different visuals because that is something that they often have to do when they learn with multiple visuals. One example is ChemTutor, an educational technology for undergraduate chemistry. So here, explanation activities help students explain how to translate from one visual to another. Intuition activities give students practice with many quick translation tasks. And I've done several studies that show that students do actually learn best if they receive both types of activities. How did I test that? Well, I created versions of my educational technologies that either did or did not contain explanation activities, and that either did or did not contain intuition activities. And I tested students' knowledge, say, about chemical bonding before and after they worked with the technology. And I found that the pre to post-test learning gains were actually highest for those students who had received both explanation activities and intuition activities. And I've done studies like that with ChemTutor and also with the Fractions Tutor, which is an educational technology for elementary school fractions learning. And if you're interested in the details, you'll find some links to articles below. But yeah, it seems like we do need both, learning by explaining and training our intuitions. So, which should we do first, explanation activities or intuition activities? That's what I'll talk about in the next video. So if you don't want to miss it, please subscribe.